So here's our video for AP Stats. We're looking at Chapter 6, Lessons 1 and 2 about probability distributions, random variables. So let's start by talking about just two types of random variables, discrete and continuous. Discrete variables would be, they'd have to take on a fixed set of values, but not the values in between. For example, the number of students in a class is discrete. We could not have 7.3 students. Continuous would be the total weight of the students in the class. We could have 753.2 kilograms as their mass. And we could have their weight in pounds as their is also continuous. So a nice example is shoe size is discrete. It goes by half sizes, so 7, 7.5, 8. But the length of your foot would be continuous. So it's important to know that distinction. I want you to think about what is a random variable and how are discrete random variables different from continuous. But before we go on, let's look at this in the context of a problem. So there's a lot of different online fantasy sports games now. So this is an example with one of those in mind, though this does not come from any specific one. So you pay $2 to play this game, and the greatest outcome, the one that gets people to sign up, is you can win up to $20 for that $2 play. The other outcomes are you get your money back, so you get your $2. You get $1 after paying the $2, so that means you paid 2, you won 1, so you lost $1, or losing your money altogether. Analysis determines that paying $2, you win $20 about 2% of the time, so very seldom, about 1 out of 50 times. You get no money, meaning you get your money back about 13% of the time. You lose $1, meaning you paid 2 and you got 1 back about 35% of the time, and you lose your 2 about half the time. So this would give us the following probability distribution, where the outcome is on top and the likelihood of it occurring is on the bottom. So your free response question is going to be in regard to this. So I'm going to show you the question and then we're going to go over how to answer it. First, you're going to verify that it's a legitimate probability distribution. Remember, that's a review, so think about what's involved with that. And then calculate the expected value or mean, mu of x, the standard deviation, and the variance. So we'll go over 2, 3, and 4 right now. Remember that probability distributions give all possible values of a random variable and their probabilities. Remember that the total of all probabilities needs to be 1 or 100%. 1 if we're talking in proportions, 100% if we're working in percents. Shape, center, and spread are still the ideas we look at with a probability distribution. Looking at the histogram or the density curve to determine the shape. Finding the center, which is the mean or the expected value. We're going to go over that in just a second. And the spread, usually defined by the standard deviation. We can also, instead of a histogram, use a density curve. Remember, that's like a smooth curve. You could picture chopping off the little corners of the histogram and drawing a smooth curve over the top of it. And you could find the area in between two values underneath the curve to represent how often that would occur. So that area underneath represents the probability of that range of values. So when we write the probability of x being greater than or equal to 1 equals 7/8, this is in flipping coins, 3 coins, and recording the number of heads. We're saying that in the long run, remember that's key when interpreting probability, about 87.5% of the time we would get 1 or more heads. So let's look at the probability distribution and how you're going to answer your free response. We have values, we have the probabilities. Remember, the total of the probabilities needs to be 1 or 100%. Here we have a discrete variable. Just like in our example, we have a discrete one because you're either losing 2 or losing 1, losing none, or winning 20. There's no value in between. Keep in mind these ideas for probability distributions. To find the probability of any event, add the probabilities that satisfy that event. So just like we looked at before, greater than 1 or more heads and 3 flips. Expected value. What we do is we take the value and we multiply it by its probability. This is very similar to how your grades are determined with a weighted average. So it's 40% of your quarter 1 grade times 40% of your quarter 2 times 20% of your final grade. Similar idea with how I do the grades in valuing tests, homework, quizzes. So here you would take the value x1 and multiply it by its probability. Add that to x2 and multiply it by its probability. Remember, probabilities in the decimal form or proportion form. And you would add those up. So x1 times p1 plus x2 times p2 plus x3 times p3. And our answer there is the expected value of the outcome, or in the long run, how much we would expect per play. So in case of ours, it would be how much we would expect to win or lose in the long run every time we played this fantasy sports game. To find the variance, we need that mean first, that expected value first, which is what mu sub x represents here. We would take each value and find how far it is from the mean and square it. Remember, because we just want to know average distance, we're not concerned whether it's above or below, and then multiply it by the probability. So again, this is the variance here that I'm pointing at the bottom. Then you'd add that to the distance that your second value is from the mean, squared times the probability, and so on. Once we had that whole answer for all of our values, if we took the square root of it, we would have the standard deviation. So now would be a good time to pause, take that in, look over this material in Chapter 6, Lesson 1, and then just go ahead and start filling in your free response, and then push play again. So just a note on continuous random variables. Ours is discrete here. Since a continuous variable, like if you imagine the numbers between 0.3 and 0.7 here, there's an infinite amount of numbers. We could just keep writing out numbers and go forever. So when we look at continuous and discrete variables, think about how discrete ones can only take on certain values, continuous can take on all the values in an interval, and we define intervals for continuous ones for that reason in this way. Then to find the probability of that interval, we look at, we mark those off on the x-axis and go up to our curve and find the area underneath, which if you're in calculus would be like taking the integral from those 2 points under the curve. And in stats, we do that. You can use calculus to do that, or you could also use the calculator functions and the table that we use. Okay, in Chapter 6, Lesson 2, we look at transformations and combining random variables. So transforming is much like we talked about in Chapter 2, where we add, subtract, multiply, or divide by a constant, and it's very similar in that regard. And then combining two sets of data would be like playing 1 week and playing a second week, and finding the expected value of those 2 weeks, or finding the standard deviation of those 2 weeks. Some other types of questions we could answer: difference in mean salaries for men and women, a new drug versus a currently used drug for survival rates, and looking at combining those. So this should be a nice piece to review what we've already gone over. Adding and subtracting a constant to measures of center and location. So adding and subtracting a constant to the whole probability distribution adds that same value, or subtracts it, if it's like adding a negative number, to measures of center and location. So mean, median, quartile, so on. It doesn't change the shape at all. Picture the whole thing shifting. Right for a positive number, left for adding a negative number, subtracting a positive. Multiplying and dividing. Multiplies and divides each observation by that number. It also multiplies the spread. So by multiplying by a number bigger than 1, the spread increases. By a number smaller than 1, it decreases. Remember, spread is measured by the IQR, standard deviation, and the range. Dividing is like multiplying by a number less than 1. So multiplying and dividing fall in the same category. The shape is not changed. So notice the shape doesn't change in either of these situations. Measures of center and location change when adding and subtracting. Measures of center and location, as well as measures of spread, change when multiplying and dividing. For mean and standard deviation, here we have y equals a plus bx, a linear transformation where we're doing both. We're adding a constant and we're multiplying by a constant, and we're adding a constant. So the probability distribution of y has the same shape because shape's not changed by either. Here's how we calculate our new mean, and then we look at this to calculate our standard deviation, the absolute value of b times the standard deviation of x, since we're multiplying by b, and adding a value doesn't change the standard deviation. Now if we're looking at the mean, or the expected value, by combining random variables, remember combining variables is different in the sense that we would have like playing for 2 different weeks. It's 2 different probability distributions. It's like we're combining them. So in general, the mean of the sum of several random variables is the sum of their means. So to find the new mean, add the 2 previous means together. One thing that's different, so if we're subtracting, we would subtract there. One thing that's different though, and this is a key one that always pops up on the AP and will be a focus in our class too, is whether we add or subtract 2 variables. There's more variables means more variance. So even if I'm subtracting 2 random variables, I add their variances to find my new variance. And the variances add, but standard deviations don't. So very key thing there. So back it up if that's giving you trouble. More variables, more variance. So that means even if we're subtracting two random variables, we add their variances. And standard deviations don't add. So those are the two common mistakes, that students want to add standard deviations, or that when we subtract two random variables, they want to subtract the variances. So don't make either of those two common mistakes. Here's a little example that you can look over. You can pause now about a Jeep tour and the probability distribution. We're looking at the expected value, the variance. So this is nice, just review. You can try this on your own, calculating those things, and then check here. Also a way to check your free response. Independence is very similar, as we've talked about before. If knowing whether any event involving X has occurred doesn't change the chance of Y, or any occurrence involving event Y, then they're independent random variables. So that's a key idea, and one that we've gone over quite a bit in first semester and on our final exam. So if they are independent random variables, meaning one occurring does not affect the chance of the second random variable, then we, as I said, more variables, more variance. Standard deviations don't add. But if we wanted the new standard deviation, we would square the standard deviations of our two distributions to turn them into variances, add them up, and then take the square root to find our new variance. So this only applies to independent random variables. Otherwise, things change. And again, I'm putting a big emphasis on this, but the mean, our new mean, so for the difference, we'd subtract means to find our new mean. However, variances we always add. Even if we're subtracting the difference of two random variables, the variances add. And that's a very key thing to take away from this video in this section. Next question, we are trying to determine if there's a discrepancy between the mean salaries of men, which is going to be represented in mu sub m, and women, mu sub w in California. To do so, we subtract the women's salaries from the men's. So mu sub m minus mu sub w. What happens to the expected value of the mean? Mu sub d, that's the mean of the differences, and the variance, which is sigma d squared. That's how we represent variance of our new data set, the results. You have your 5 answer choices here. You can look back on the video we just went over. Take a look at the Chapter 6, Lesson 2 summary in your book, and look over some of the example problems there to get a better feel for this.